What if the most powerful inventions of the modern world were not born from comfort, wealth, or applause, but from a mind haunted by invisible forces, a mind that looked at lightning and did not see danger, but language, a mind that listened to the silence between electrical pulses and wondered whether the universe itself was speaking? Nikola Tesla was not merely an inventor. He was a man standing at the threshold between the known world and the unseen machinery behind it. Electricity, magnetism, frequency, vibration, resonance to him, these were not just scientific terms. They were the hidden grammar of nature, the secret code by which the universe moved, pulsed, and breathed. And yet, the deeper we look into Tesla's life, the stranger the story becomes. Here was a man who helped give humanity alternating current, wireless technology, radio principles, remote control, rotating magnetic fields, and visions of clean energy decades before the world was ready to understand them. But alongside these undeniable achievements were ideas so strange, so daring, and so far ahead of their time that even today they seem to stand halfway between science and prophecy. A machine to draw energy from cosmic rays, a method of sterilizing the human body with electricity, a device that he believed could detect signals from civilizations beyond Earth, a tower that might have transmitted energy without wires, a dream of controlling weather through the electrical body of the planet itself, and in the final years of his life, a mysterious weapon he claimed could end all war. Some of these ideas were real experiments, some were theoretical visions, some remain controversial, some may have been misunderstood, but all of them reveal one undeniable truth. Tesla did not see the world the way ordinary men saw it. Where others saw wires, he saw currents in space. Where others saw machines, he saw systems of energy. Where others saw matter, he saw vibration. Where others saw darkness, he imagined invisible light. And if even a fraction of his forgotten ideas were possible, then the story of modern science is not only a story of progress, it is also a story of what was ignored, what was lost, and what humanity may still not be ready to touch. There are names in history that do not fade with time. They remain suspended in the collective memory like stars after sunset, distant, almost unreachable, yet still burning. Nikola Tesla is one of those names. He was a brilliant inventor, an electrical engineer, a visionary whose intelligence seemed almost unnatural to those who met him. His inventions did not simply improve the world. They changed the way humanity understood power itself. Before Tesla, electricity was still a wild and dangerous force, something trapped inside laboratories, factories, and early power stations. After Tesla, it began to move through cities, illuminate homes, drive machines, and reshape civilization. His creativity opened a door into a new reality, a world where old limits broke apart, where invisible forces could be measured, commanded, amplified, and transmitted. What many people in his time dismissed as madness would later become the foundation for technologies that define our age. Tesla's inventions were not merely mechanical devices. They were early signals from a future that had not yet arrived. But who was this man who seemed to think in lightning? Nikola Tesla was born in 1856 inches, Smiljan, then part of the Austrian Empire, in what is now Croatia. He was one of 5 children in a family that valued education, discipline, and imagination. His father was a Serbian Orthodox priest and a writer, a man of words, faith, and tradition. He wanted his son to follow a religious path and enter the church. But Tesla's destiny was not in the pulpit. It was in the invisible field. His mother, though not formally educated in science, possessed a remarkable inventive gift. In her spare moments, she created small household devices and tools with her own hands. She could take the simplest problem of domestic life and imagine a mechanical solution. For the young Tesla, this was more than childhood influence. It was initiation. He saw that invention was not an act of magic. It was observation sharpened into form. It was nature translated into design. From an early age, Tesla became fascinated by mechanisms, energy, light, and the unseen forces that made physical things move. He resisted his father's wish that he join the church and instead turned his mind toward mathematics, physics, and engineering. After completing secondary school, he studied engineering and physics in the 1870s. He later gained practical experience working in the electrical power industry, including at Continental Edison in Europe in the early 1880s. It was during this period that Tesla began developing one of the great ideas of his life, the induction motor. But like many visions born too early, it did not immediately receive the attention it deserved. Tesla tried to interest engineers, investors, and scientific circles in his idea, but he was not yet famous. He was not wealthy. He was not protected by an institution powerful enough to force the world to listen. And so, at the age of 28, he made a decision that would alter the course of electrical history. In 1884, Nikola Tesla left Europe for the United States. He arrived in America with little more than the clothes on his back and a letter of introduction addressed to one of the most famous inventors and businessmen in the world, Thomas Edison. The meeting between Tesla and Edison has become one of the most famous encounters in the mythology of modern invention. On one side stood Edison, practical, aggressive, commercially brilliant, already a giant in the electrical industry. On the other stood Tesla, elegant, intense, visionary, less interested in immediate profit than in the hidden mathematical beauty of nature. Edison was impressed by Tesla's talent and his radical ideas about electrical power. He hired him quickly, and for a short time, the two men worked in the same orbit, pushing late into the night to improve electrical systems and machines. But their minds were built differently. Edison was a man of trial and repetition. He tested, failed, adjusted, and tested again. His genius was persistent and industrial. He believed in experimentation through accumulation, in conquering problems through labor, pressure, and practical iteration. Tesla's method was almost the opposite. He claimed that he could design machines in his mind before building them. He imagined devices in complete detail, ran them mentally, observed their weaknesses, corrected them, and only then committed them to physical form. To Tesla, a machine was not merely assembled, it was first summoned. This difference was not just intellectual, it was philosophical. Edison saw electricity as a business, a product, a network of lamps, wires, meters, and customers. Tesla saw electricity as a universal principle, a force that could be tuned, transmitted, and perhaps one day drawn from nature itself. Their partnership did not last. After only a few months, Tesla and Edison parted ways. The official reasons were complex, but the deeper truth was simple. Two powerful minds were moving in opposite directions. Edison was focused on commercial success and the expansion of direct current systems. Tesla was looking beyond the limits of direct current toward alternating current, rotating magnetic fields, and a new electrical architecture for civilization. In 1885, Tesla received funding for a company bearing his name, the Tesla Electric Light Company. Investors tasked him with developing improved arc lighting systems. Tesla succeeded, but after the work was done, he was pushed out of the enterprise. For a time, the man who would one day help electrify the world was forced into manual labor simply to survive. Imagine that picture clearly. A mind filled with motors, frequencies, magnetic fields, and visions of global energy digging ditches to earn enough money to eat. But destiny had not finished with Tesla. After 2 years of hardship, he received new financial backing for another venture, the Tesla Electric Company. This moment changed his life. It gave him the chance to bring his great electrical ideas into the world. And once he did, the modern age began to hum with a new kind of power. How did Nikola Tesla change the world? The answer is not contained in a single invention. It is scattered across motors, generators, radio principles, wireless experiments, fluorescent lighting, X-ray research, remote control, high-frequency currents, rotating magnetic fields, and the architecture of electrical power itself. Throughout his career, Tesla discovered, designed, and developed ideas behind some of the most important technologies of the modern era. Some of his inventions were patented under his name. Others were later associated with different inventors. Still others remained incomplete, abandoned, or too ambitious to be built in his lifetime. But the central pillar of Tesla's legacy was alternating current AC power. At the time, Edison's direct current system had serious limitations. It was difficult to transmit efficiently over long distances. To electrify an entire nation, something more powerful, more flexible, and more scalable was needed. Tesla believed alternating current was the answer. AC electricity could be transformed to higher or lower voltages, transmitted over great distances, and distributed widely. It was not just a technical improvement, it was a new electrical nervous system for civilization. In 1887, Tesla's alternating current system attracted the attention of George Westinghouse, an American engineer, entrepreneur, and industrialist searching for a way to deliver electricity across long distances. Westinghouse saw what others had missed. Tesla's system was not a curiosity, it was the future. The adoption of alternating current triggered a revolution. AC power spread rapidly and became the dominant electrical standard used across the world. To this day, the electricity flowing through homes, factories, and cities is built upon the principles that Tesla helped bring into practical use. But Tesla's work did not stop there. Near the end of the 19th century, He patented the Tesla coil, a resonant transformer circuit capable of producing high-voltage, high-frequency electricity. The Tesla coil became central to his experiments with wireless transmission, radio frequency energy, and electromagnetic phenomena. To the public, the Tesla coil seemed like a spectacle: lightning leaping from metal spheres, blue-white arcs crawling through the air, a man standing calmly near forces that appeared almost supernatural. But to Tesla, these displays were not entertainment. They were evidence. Evidence that energy could move in ways the world barely understood. Evidence that the air itself might become a conductor. Evidence that earth, atmosphere, and electricity were not separate things, but parts of a single system. With the Tesla coil, he explored fluorescence, X-rays, radio waves, wireless electricity, and even the idea of electrical energy traveling through the earth. And from this field of experimentation came ideas that sounded impossible in his own time, and still sound dangerous, beautiful, and unfinished today. One of Tesla's most haunting ideas was the possibility of drawing energy from cosmic rays. To most scientists of his time, the concept seemed closer to fantasy than engineering. The universe was full of invisible particles, radiation, and energetic phenomena, but the thought of harvesting them as a usable source of power felt impractical. Tesla did not agree. He believed nature contained immense reservoirs of energy that humanity had barely begun to recognize. If electricity existed in storms, in the atmosphere, in sunlight, in the earth, and in cosmic radiation, then perhaps energy scarcity was not a permanent law. Perhaps it was only a failure of imagination. According to this theory, tiny energetic particles from space constantly strike the Earth. Tesla speculated that a properly designed machine might capture or convert some of this energy into practical power. Today, we must be careful. There is no final proof that Tesla ever created a working machine capable of extracting free, usable energy from cosmic rays in the way some legends describe. The idea remains speculative, and much of what surrounds it belongs to the shadowy border between documented science, theoretical possibility, and later mythology. But the deeper point is important. Tesla was not content to burn fuel forever. He imagined energy as something already present in the environment, waiting not to be produced but received. This idea echoes through many of his later projects: wireless energy, atmospheric electricity, resonance, earth currents, and the dream of a planet powered not by exhaustion, but by harmony with natural forces. In Tesla's imagination, the universe was not empty. It was charged. It was alive with motion. It vibrated with energy on scales too large and too subtle for ordinary instruments to detect. And if humanity could learn to tune itself to those forces, perhaps machines would no longer need to devour the earth to keep civilization alive. That thought remains electrifying, because even now, in an age of solar panels, wind turbines, hydroelectric systems, batteries, fusion research, and quantum materials, we are still chasing a question Tesla asked more than a century ago: can civilization be powered without destroying the world that carries it? Among Tesla's stranger ideas was a concept sometimes described as cold fire. The phrase itself sounds like a contradiction: fire that does not burn, flame without injury, sterilization without water or soap. The idea was connected to Tesla's fascination with electricity as a purifying force. He believed that electricity could destroy germs, and he imagined a process in which a person might stand on a metal plate and be surrounded by high-voltage alternating current. In some descriptions, the voltage was imagined as reaching millions of volts, creating something like an electrical aura around the body. To an observer, it might have looked like a ghostly flame, not fire in the ordinary sense, but a field of electrical discharge. The reasoning behind the idea was that the human body and skin can conduct electricity in certain conditions, and high-voltage electrical fields can produce ozone, which has disinfecting properties. But here, again, mystery must be separated from certainty. The concept was bold, but dangerous. Safety, cost, practicality, and medical risk made such an invention impossible to bring into ordinary life. There is no evidence that cold fire ever became a reliable technology for domestic cleaning or human sterilization. Still, the idea reveals the strange direction of Tesla's mind. He did not think of electricity only as power for lamps and motors. He thought of it as a cleansing force, a healing force, a force that could interact with life itself. He imagined the body not only as flesh, but as an electrical organism. The nerves, the brain, the heart, all of them pulse with bioelectric signals. Every movement, every sensation, every heartbeat is partly electrical. In that sense, Tesla's fascination was not entirely absurd. Modern science now studies bioelectricity, neural stimulation, electromagnetic therapy, sterilization technologies, and the effect of electrical fields on biological systems. Tesla may not have had all the answers, but he was asking questions that later generations would continue to explore, and this is where his story becomes difficult to classify. Was he a scientist? An engineer? A dreamer? A mystic of electricity? Perhaps he was all of these at once, a man attempting to build machines at the outer edge of what his century could understand. Then there was the mystery of communication beyond Earth. Tesla claimed that, during his experiments, he received unusual sounds unlike anything he had heard before. Some were described as rhythmic clicks, almost like a code. To Tesla, this raised a staggering possibility. Could intelligent life exist beyond Earth? Could the universe contain civilizations transmitting signals through the ether, through space, through electromagnetic waves? At the time, the idea was extraordinary. Radio itself was young, wireless communication was still emerging. Humanity had barely learned to send messages across oceans, and Tesla was already imagining messages across planets. He believed that with the right apparatus, it might be possible to communicate with distant civilizations, perhaps even life on Mars. Today, we know that many natural phenomena can generate radio signals. Planets, stars, storms, magnetic fields, and cosmic events all produce electromagnetic patterns. It is entirely possible that the signals Tesla heard were natural, terrestrial, or instrumental in origin. There is no confirmed evidence that Tesla contacted extraterrestrial intelligence, but again, the important part is not whether the claim was proven. The important part is the scale of the question. Tesla was thinking beyond Earth at a time when most people were still adjusting to electric lamps. He understood that radio waves could travel invisibly through space. He understood that messages did not require wires. He understood that the cosmos was not silent in the electrical sense, and in this, he anticipated a modern scientific dream. Today, radio telescopes scan the heavens. Scientists search for signals from distant stars. Programs dedicated to the search for extraterrestrial intelligence listen for patterns that might reveal another mind somewhere in the dark. Tesla's methods were primitive compared to modern astronomy. His interpretations may have been mistaken, but his instinct that the universe might be filled with signals was not foolish. It was prophetic. Because every day, Earth itself sends radio waves into space. Television broadcasts, radar pulses, satellite transmissions, military signals, cell networks, and deep space communications all leak outward into the cosmic ocean. We are no longer only listening. We are also speaking. And somewhere, far beyond the reach of our instruments, perhaps another civilization is asking the same question Tesla once asked in the glow of his machines. Is anyone there? One of the most controversial ideas associated with Tesla is the possibility of influencing weather through electrical forces. Weather is among humanity's oldest fears. Storms destroy cities, droughts starve nations, floods erase villages, lightning splits the sky with a power that seems almost divine. To control weather would be to touch one of nature's highest thrones. Tesla believed that Earth was not merely a rock spinning through space. He saw it as an electrical body, surrounded by atmosphere, magnetic fields, charged layers, and resonant systems. In modern terms, we know the Earth has a magnetic field. We know the ionosphere contains charged particles. We know lightning, solar storms, and atmospheric electricity are real phenomena. We know radio waves can interact with layers of the upper atmosphere under certain conditions. Tesla imagined that by using powerful electrical waves, perhaps one could influence atmospheric behavior, alter local conditions, or even make dry land more fertile. Some later theories go much further, claiming that Tesla's weather control concepts may have been suppressed, weaponized, or secretly used. According to such interpretations, extreme weather and climate instability are sometimes framed as evidence of hidden technologies. But such claims must be treated carefully. There is no public proof that Tesla built a working weather control machine capable of manipulating storms or climate in the dramatic way some stories suggest. Climate change and extreme weather have complex scientific explanations involving greenhouse gases, ocean systems, atmospheric dynamics, land use, and natural variability. Still, Tesla's deeper intuition remains fascinating. He believed the atmosphere was electrical. He believed the planet could resonate. He believed invisible waves could shape physical reality. And in some ways, modern science has confirmed parts of the framework, even if not the extreme conclusions. Atmospheric electricity is real. The ionosphere is real. Electromagnetic propagation is real. Weather systems are influenced by energy, charge, heat, pressure, and planetary dynamics. The mystery, then, is not whether Tesla controlled the weather. The mystery is how far ahead he was in imagining Earth as an interconnected energetic system. To Tesla, nature was not a collection of separate objects. It was a grand circuit. Every storm was a discharge. Every wave was a message. Every magnet, every cloud, every spark, every vibration was part of an immense machine whose design humanity had only begun to read. For all the mystery surrounding Tesla, some of his most important achievements were not speculative at all. They were built into the world. One of the clearest examples is hydroelectric power. Tesla became one of the great figures in the rise of renewable energy, especially through his connection to the Niagara Falls power project. 9 of the 12 patents used in the design of one of the world's first major hydroelectric power plants at Niagara Falls were associated with Tesla. This was not merely an engineering milestone, it was symbolic. Niagara Falls had long been seen as a natural wonder, a spectacle of water and gravity, noise and mist, beauty and violence. But Tesla saw something more. He saw falling water as stored energy. He saw nature not as scenery, but as power in motion. As a child, Tesla had heard stories about Niagara Falls, and the idea of harnessing the energy of falling water stayed with him. To most people, the falls were majestic. To Tesla, they were a generator waiting to be understood. In the age of the Industrial Revolution, humanity was burning coal and other fossil fuels at an accelerating pace. Factories smoked, cities darkened under soot. Progress came wrapped in pollution. Tesla believed this was not the only path. He understood that fossil fuels were finite, dirty, and ultimately unsustainable. He imagined a future built on cleaner sources of power, water, wind, sunlight, and natural forces that did not require humanity to poison its own air. This is one of the reasons Tesla feels so modern. He belongs to the 19th century, yet he speaks directly to the 21st. Today, the world is again asking how to power civilization without exhausting the planet. We speak of renewable energy, clean grids, decarbonization, sustainability, and climate responsibility. Tesla was asking similar questions long before these terms became common. For him, energy was not merely a commodity. It was a moral question. What kind of civilization burns the very world that sustains it? What kind of science ignores the generosity of nature? What kind of future is built on smoke when rivers, sunlight, wind, and planetary forces are already moving all around us? Niagara proved that nature could be a partner. It showed that civilization did not always need to dominate natural forces through destruction. Sometimes, it could listen. It could align. It could convert motion into light. Another battlefield in Tesla's legacy was wireless communication. History often credits Guglielmo Marconi with the invention of radio telegraphy. Marconi's achievement in sending wireless signals across the Atlantic became one of the most celebrated technological events of the early 20th century. But the story is more complicated. Tesla had already developed technologies and principles essential to wireless transmission. He recognized that the Tesla coil could transmit messages. He was preparing to test wireless systems when disaster struck in 1895. His laboratory burned, destroying equipment, notes, and years of work. At first, Tesla did not view Marconi as a serious rival. He reportedly saw him as a man building upon technologies that Tesla himself had pioneered. In 1901, Marconi successfully transmitted a radio signal across the Atlantic, and he eventually received recognition and patents. But the U.S. patent system had previously rejected some of Marconi's claims because they overlapped with Tesla's prior work. This is not a simple story of one inventor stealing everything from another. It is a story of how invention often happens in overlapping waves. Ideas emerge through networks, patents, experiments, investors, rivalries, and legal battles. One man imagines the principle, another builds the apparatus, a third commercializes it, a fourth receives the fame. But Tesla's role in wireless technology cannot be erased. He understood that communication did not need a wire. He understood that information could ride in visible waves. He understood that the air around us, empty to the eye, could become a highway for signals. This was a revolutionary realization. Today, the modern world lives inside Tesla's dream without noticing it. Phones speak without wires. Satellites circle the Earth. Wi-Fi fills homes and offices. Radio waves carry music, voices, navigation, military commands, emergency alerts, and data. Every second, billions of invisible messages pass through walls, bodies, clouds, vehicles, and cities. The air is not empty. It is crowded with human intention. In Tesla's time, this would have seemed like sorcery. To him, it was only physics waiting for courage. But Tesla's greatest dream was even larger than wireless communication. He dreamed of wireless power, not just messages sent through the air, but energy itself. A world without tangled wires. A planet where electricity could be transmitted across vast distances and received wherever needed. A civilization in which a simple antenna might draw usable power from a global system. This dream led to one of the most mysterious projects of Tesla's life, Wardenclyffe Tower in New York. Officially, the tower was presented as part of a wireless telecommunications system, but Tesla's deeper ambition may have been far more radical. He wanted to build a system capable of transmitting power without wires, perhaps through the Earth itself and the atmosphere above it. The idea was bold beyond measure. Tesla had already demonstrated short-range wireless lighting experiments. He could illuminate lamps without conventional wires under controlled conditions, but scaling that principle to a global system was a far greater challenge. He found financial backing from J.P. Morgan, one of the most powerful financiers in America. Construction began. A tower rose over Long Island like a metallic monument to the future. But then the project collapsed. Funding was withdrawn. One interpretation says Morgan lost interest when he realized the system might not be easily metered or monetized. If power could be transmitted freely through the air, how would investors charge for every watt? How would industry control access? How could such a system become a business empire? This interpretation has become one of the great legends of Tesla's life. The genius who tried to give the world free energy, stopped by financial powers that could not profit from abundance. But again, caution is necessary. Wardenclyffe's technical feasibility remains debated. Wireless power transmission is possible over limited distances and in specific forms, but Tesla's planetary system was never completed or proven at the scale he envisioned. Still, the symbolism is overwhelming. A tower built to connect the Earth. A dream too large for its financiers. A machine unfinished. A future dismantled. After Tesla lost funding, the project decayed. He fell into debt. Eventually, Wardenclyffe Tower was torn down and sold for scrap. There is something almost tragic in that image. A structure built to transmit invisible power across the planet, cut apart for metal value. A vision of abundance reduced to debt repayment. And yet, the idea did not die. Today, scientists and engineers still explore wireless charging, microwave power transmission, resonant inductive coupling, satellite solar power, and energy transfer without physical contact. Tesla's dream remains unfinished, but not extinguished. It still flickers in every wireless charger, every inductive system, every experiment that asks whether energy can travel without copper veins. Perhaps Tesla's tower was premature. Perhaps it was impossible in the form he imagined. Or perhaps it was the first silhouette of a technology humanity has not yet fully mastered. As Tesla grew older, the world's judgment of him began to shift. The young man who had amazed New York society with his electrical demonstrations became, in the eyes of many, an eccentric old inventor. His ideas seemed increasingly strange. His finances weakened. He lived more privately, often in hotels, sometimes moving from one place to another as debts accumulated. People called him a genius, but they also called him impractical, brilliant, but unstable, visionary, but lost in dreams. Part of this reputation came from his unusual habits. Tesla was intensely concerned with cleanliness. He disliked germs and avoided touching things he considered contaminated. He washed his hands repeatedly. He used many napkins while dining. He was known for wearing gloves and for having strong aversions to certain textures, shapes, and objects. He also had a deep fascination with numbers, especially repeated patterns. The numbers 3, 6, and 9 became associated with his personal rituals and later with legends surrounding his worldview. He reportedly walked around buildings 3 times before entering. He performed actions in multiples of 3. At meals, he could use 18 napkins to polish his utensils, never using the same one twice. Modern observers often interpret these behaviors as signs of obsessive-compulsive tendencies, but in the mythology surrounding Tesla, they became something else: signs of hidden numerical knowledge, secret geometry, or mystical understanding of the universe. We must be careful here. There is no proof that Tesla possessed a secret mathematical key based on 3, 6, and 9 that unlocks all reality. Many exaggerated claims about this have grown online and in popular culture, but Tesla did possess a profound respect for pattern. He knew that nature is built from repetition, ratio, frequency, wave behavior, and symmetry. Electricity oscillates, sound vibrates, light has wavelength, Machines rotate. Alternating current rises and falls in cycles. To Tesla, numbers were not dead symbols. They described motion. They mapped hidden rhythms. They gave form to invisible forces. So even if the legends around 3, 6, and 9 are often overstated, they speak to something real in Tesla's mind. The conviction that the universe is mathematical, rhythmic, and deeply ordered beneath the surface of chaos. He died on the 7th of January 1943 in New York City at the age of 86. He had lived and worked in America for nearly 60 years. By the end, he was not surrounded by wealth or industrial triumph. He was often alone. One of his most famous late-life habits was feeding pigeons in New York City, especially in the area he knew so well. The man who dreamed of electrifying the planet spent his final years caring for birds in the streets of the Big Apple. It is one of the strangest and most human images in the history of science. A mind that reached toward the stars. A hand scattering crumbs at his feet. After Tesla's death, his legacy did not disappear. It transformed. In 1994, a sign reading Nikola Tesla Corner was installed near the location of his former laboratory at the intersection of 40th Street and 6th Avenue in New York City. But by then, Tesla had become more than a historical inventor. He had become a symbol. To some, he was the forgotten father of the electrical age. To others, he was the genius robbed by corporations. To others, still, he was a near-mythic figure whose secret inventions were hidden, suppressed, or destroyed. And standing at the center of much of this mythology is Thomas Edison. For many modern viewers, Edison has become the villain in Tesla's story, the powerful businessman who blocked Tesla, mocked him, stole from him, and kept the world from recognizing his genius. But is that version of history true? Or is it another electrical illusion, dramatic, compelling, but incomplete? The image of the mad scientist, the misunderstood genius, the lonely prophet of technology, has long fascinated the public. For decades, Tesla has been portrayed in books, films, documentaries, and internet culture as a heroic outsider whose achievements were ignored while others took credit. In these stories, Edison often becomes the shadow figure, the practical, ruthless operator who stands in the way of revelation. But historical records complicate this picture. Tesla's achievements were not completely ignored in his lifetime. He received public recognition, scientific respect, and major honors. In his own era, many engineers and scientists understood that his contributions to electrical power were immense. In 1896, the physicist Lord Kelvin reportedly praised Tesla's contributions to electrical science in extraordinary terms. Tesla was widely admired for his work with high-frequency electricity and alternating current, and one of the most important honors he received was the Edison Medal. This detail is important. If Edison had truly been a lifelong enemy determined to erase Tesla, then the fact that Tesla received an award bearing Edison's name becomes much harder to fit into the simplified legend. On the 18th of May 1917, the American Institute of Electrical Engineers awarded Nikola Tesla the Edison Medal. The date came 29 years after Tesla had received patents for his great polyphase motor system, one of the inventions that helped make modern electrical power possible. By then, many of the old conflicts between Tesla and Edison had faded into history. The medal recognized Tesla's enormous contributions, lighting cities, powering industry, and transforming electrical energy into mechanical motion through motors. At the ceremony, Bernard A. Behrend famously emphasized that without Tesla's work, the wheels of industry would stop turning, electric cars and trains would halt, and towns would remain dark. That is not the language used for a forgotten failure. It is the language reserved for a man whose work had become part of civilization's skeleton. Tesla accepted the honor, and during the evening, he spoke about Edison with respect. He remembered arriving in America and meeting Edison. He described seeing in him a remarkable man, someone without formal higher training, who had achieved extraordinary things through sheer force of effort. Tesla admitted that, at the time, he felt ashamed of having spent so much of his own youth studying languages, literature, and books while Edison had been building, testing, and producing. But Tesla also made clear that he and Edison were fundamentally different. He said that persistence and hard work were almost the only qualities they had in common. Tesla did not rely on endless physical models, drawings, and repeated experiments in the same way Edison did. He believed he could construct machines mentally, test them inside the imagination, and refine them before they ever touched metal. This contrast became one of the great philosophical divisions in the history of invention. Edison believed in labor. Tesla believed in vision. Edison trusted repeated experiment. Tesla trusted mental simulation. Edison moved through matter. Tesla moved through thought. Neither method was simple. Neither man was ordinary, but their difference helped create the legend of conflict that followed them both. When Edison died in 1931, Tesla offered comments that were both critical and respectful. He criticized Edison's experimental method, suggesting that Edison would search for a needle in a haystack by examining every straw one by one, rather than pausing to calculate where the needle might be. Tesla believed Edison wasted enormous effort because he did not use enough theoretical analysis. Yet even in criticism, Tesla acknowledged the miracle of Edison's success. He suggested that few, perhaps no others, could have achieved so much through Edison's method. This was Tesla's nature. He could admire and attack at the same time. He often criticized famous figures in science. He rejected major ideas that later became pillars of modern physics, including aspects of quantum theory and Einstein's relativity. In 1935, he spoke harshly about relativity, describing it as a theory that dazzled people while concealing errors. He also rejected the concept of wave-particle duality and claimed that he could make electrical currents move faster than light, a statement that modern physics does not support in the simple way it may sound. These positions show us something important. Tesla was brilliant, but not infallible. He was visionary, but not always correct. He saw far into some areas and resisted breakthroughs in others. The public image of Tesla as a perfect prophet of science is too simple. The truth is more interesting. He was a man of genius and contradiction. He illuminated the world, but remained skeptical of some of the very revolutions that would define 20th century physics. He anticipated wireless technology, renewable energy, and global communication, yet he also clung to ideas that later science would challenge. That tension makes him not less fascinating, but more human. In his final years, Tesla devoted much of his attention to a mysterious weapon he claimed could bring peace to the world. The press called it a death ray. Tesla himself preferred a different framing. He believed the device could project powerful beams or particles capable of defending nations so completely that war would become impossible. According to his vision, if every country possessed a defensive shield so powerful that invasion could not succeed, then peace would follow not from kindness, but from technological deterrence. Once again, the idea floats between science, speculation, and legend. No confirmed working death ray was ever demonstrated publicly in the dramatic form Tesla described. Yet the concept of directed energy weapons did not disappear. Modern military research has explored lasers, particle beams, microwave weapons, and other energy-based systems. Tesla may not have built what he claimed, but he was imagining a future in which war would be shaped by invisible forces, beams of energy, and machines operating beyond the range of ordinary weapons. By the 1930s, the man who had once electrified scientific audiences was elderly, financially constrained, and increasingly isolated. His public announcements were often treated with fascination, skepticism, or ridicule. And yet, even in decline, he remained mentally alive with invention. The tragedy of Tesla is not that he lacked recognition entirely. The tragedy is that his imagination exceeded the structures around him. He needed money, but despised being controlled by it. He needed industry, but dreamed beyond profit. He needed proof, but often spoke before the world could verify him. He needed allies, but lived increasingly alone. After his death in 1943, the first major biography of Tesla appeared in 1944, Prodigal Genius, The Life of Nikola Tesla, written by John J. O'Neill, a journalist who knew Tesla in his later years. This book helped shape the modern image of Tesla. It also strengthened the portrayal of Edison as a villain in Tesla's life. One famous story from this tradition claims that Edison promised Tesla a $50,000 reward if he could improve inefficient machines. But when Tesla succeeded, Edison refused to pay and mocked him. The story is dramatic. It fits perfectly into the legend of the exploited genius and the ruthless industrialist. But some historians have questioned whether such a promise was likely. At the time, $50,000 was an enormous sum comparable to the initial capital of a company and far beyond the normal income of a young employee. Whether the exact story is true or exaggerated, one fact remains clear. Tesla and Edison separated because their views, methods, and ambitions were incompatible. Tesla left Edison's company and eventually pursued alternating current on his own path, and that path changed history. The legend of Tesla and Edison grew stronger through retellings. In O'Neill's biography, there is a striking account of Tesla supposedly not wanting to attend the Edison Medal ceremony. Instead, he was found feeding pigeons in the street, surrounded by birds, some on his arms, some on his shoulders, some gathered around him like a living carpet. Only afterward, the story goes, did Tesla return to accept the medal and deliver his speech. It is a beautiful image, almost too beautiful. A lonely genius crowned not by kings, but by pigeons. A man honored by institutions yet more comfortable with fragile creatures in the street. But the biography left out something important: Tesla's own words of praise for Edison during the ceremony. Later, the full speech was found and published in engineering records, showing that Tesla had indeed spoken respectfully about Edison. This omission helped shape a simplified myth: Edison and Tesla as eternal enemies, locked in a moral war between greed and genius. That version is powerful storytelling, but history is rarely so clean. Edison and Tesla were rivals in ideas, yes. They disagreed profoundly, yes. Edison's campaign against alternating current was harsh and fear-driven. Public demonstrations involving the electrocution of animals were used to make AC seem terrifying. The war of currents was not polite. It involved technology, advertising, law, reputation, finance, and fear. But Tesla's greatness does not require Edison to be a cartoon villain. This is the deeper lesson. We do not need a monster in the shadows to recognize Tesla's light. His achievements stand by themselves: alternating current, polyphase motors, rotating magnetic fields, wireless experimentation, high-frequency power, remote control, hydroelectric systems, visions of clean energy, a mind that tried to read the invisible world before instruments had caught up. The truth is more mature than the myth. Tesla was not forgotten because nobody knew his name. He was partly misunderstood because his dreams were too large, his personality too unusual, his finances too fragile, and his theories too far beyond ordinary commercial appetite. He was not merely a victim. He was not merely a saint. He was a complex man whose imagination made the modern world possible and whose failures became as legendary as his successes. To understand Tesla's deeper significance, we must move beyond biography and look at the universe he believed he was entering. For most of daily life, matter appears simple: solid, liquid, gas. A stone rests in the hand, water flows through the fingers, air fills the lungs. But modern science has revealed that matter is far stranger than these familiar forms. Under extreme conditions near absolute zero, inside dying stars, within particle collisions, inside superconductors, and across quantum materials, matter behaves in ways that seem almost impossible. This is where Tesla's world of electricity, vibration, and unseen forces connects with the broader mysteries of physics. He lived before many of these discoveries were fully formed. He rejected some developments in quantum theory, yet the universe that later science uncovered was, in many ways, the kind of universe Tesla sensed: a universe where invisible fields matter, where particles behave like waves, where magnetism can levitate matter, where energy and form are inseparable, where reality changes depending on scale, temperature, pressure, and motion. One of the strangest states of matter is called a Bose-Einstein condensate. The theory began in the 1920s through the work of Indian physicist Satyendra Nath Bose and Albert Einstein. Bose was studying radiation and quantum behavior when his paper was rejected by journals. He sent it directly to Einstein, who recognized its significance and helped bring it to attention. Einstein then extended Bose's mathematics and predicted that, at extremely low temperatures near absolute zero, atoms could merge into a single quantum state. Not merely a cold gas, not a solid in the ordinary sense, but a kind of superatom, where separate particles behave as one unified entity. In 1995, scientists finally created a Bose-Einstein condensate in the laboratory, confirming the prediction decades after it was made. This form of matter behaves unlike ordinary materials. Atoms lose their separate identities and enter a collective quantum state, as if nature itself has whispered all particles into the same rhythm. For a Tesla-inspired imagination, the image is irresistible. Matter becoming one through frequency, particles surrendering individuality to a shared state, a hidden order emerging only when thermal chaos is nearly silenced. It is not Tesla's invention, but it belongs to the same realm of wonder, the discovery that reality beneath the surface is far more musical, mathematical, and mysterious than ordinary experience suggests. Another strange form of matter is degenerate matter, the material state found in some of the most extreme objects in the universe. To understand it, we must leave Earth and travel into the death of stars. When a star like the Sun exhausts its nuclear fuel, the balance between outward pressure and inward gravity begins to fail. Gravity pulls the star's material inward. The star collapses, compressing matter into extraordinary density. But matter does not collapse without resistance. Quantum physics introduces a strange rule known as the Pauli exclusion principle. It says that certain particles, called fermions, cannot occupy the same quantum state at the same time. This means that when matter is crushed to extreme density, particles resist being forced into identical states. That resistance creates what is called degeneracy pressure. In a white dwarf star, electron degeneracy pressure can hold the star up against gravity. A white dwarf may have a mass comparable to the Sun, but compressed into a volume roughly the size of Earth. Its density can be thousands or millions of times greater than ordinary matter. If the mass increases further, gravity may overcome electron degeneracy pressure. Electrons and protons are crushed together into neutrons, forming a neutron star. Now the matter becomes even more extreme. A neutron star may be only a dozen miles across, yet contain more mass than the Sunday. A single spoonful of neutron star material would weigh billions of tons on Earth. And if even neutron degeneracy pressure fails, collapse continues toward a black hole, a region where gravity becomes so intense that not even light can escape. This is the edge of known physics, a place where matter, energy, space, and time are driven into conditions that challenge human understanding. Tesla did not know degenerate matter in the modern astrophysical sense, but he understood something emotionally similar. Nature hides unimaginable power behind ordinary appearances. A quiet star may contain a future collapse. A wire may contain a field. A spark may reveal a cosmic law. A small experiment may expose a principle that governs planets, suns, and the structure of the universe. To study matter is to discover that reality is not stable in the way we assume. It transforms. Under pressure, it becomes strange. Under cold, it becomes collective. Under magnetism, it levitates. Under collision, it dissolves into primordial fire. Consider superconductors. In 1933, Walther Meissner and Robert Oxenfeld discovered that certain materials, when cooled into a superconducting state, expel magnetic fields from their interior. This became known as the Meissner effect. In ordinary materials, electrical resistance causes currents to weaken and vanish, but in a superconductor, resistance drops to zero. Currents can persist without decay. Magnetic fields are pushed away. The result can appear almost magical. Levitation. A superconducting material can float above a magnet, locked in space by quantum effects. In Type II superconductors, magnetic field lines can penetrate the material in tiny, quantized vortices. These flux lines become pinned in place, allowing the superconductor to remain stable in three-dimensional space. It does not simply float, it locks. This phenomenon, sometimes called quantum locking, seems like science fiction made visible. A thin superconducting disk can hover over a magnetic track. It can remain suspended upside down. It can resist movement as if nailed to invisible rails. Here, magnetism becomes architecture. Empty space becomes support. A field becomes a structure strong enough to hold matter in position. If Tesla had witnessed such a demonstration, one can imagine his reaction. Not surprise, perhaps, but recognition. He spent his life insisting that invisible forces were real enough to build with. Superconducting levitation proves this in a dramatic way. The air appears empty, yet the object does not fall. Nothing visible holds it, yet it remains fixed. Gravity pulls. Magnetism answers. Quantum law decides the final arrangement. And once again, the universe reveals that what we cannot see may be stronger than what we can touch. Another mysterious state is known as quantum spin liquid. The name is misleading. It is not a liquid in the everyday sense. Instead, it refers to a state in magnetic materials where the spins of electrons never settle into a fixed pattern, even at temperatures near absolute zero. To understand this, imagine every electron as carrying a tiny magnetic orientation, not spinning like a ball, but possessing a quantum property called spin. In ordinary magnets, these spins align in an orderly way, producing a stable magnetic field. This is why a magnet has north and south poles and can attract iron. But in certain materials, the arrangement becomes frustrated. The spins cannot find a single stable pattern. Instead of freezing into order, they remain in constant fluctuation, like a liquid of magnetic possibilities. This idea was first proposed by physicist Philip Warren Anderson in 1972. In 2016, researchers observed evidence of quantum spin liquid behavior in a naturally occurring material related to herbert-smithite, a copper-based mineral found in places such as Chile, Iran, Arizona, and Greece. Why does this matter? Because quantum spin liquids may help scientists understand deep principles of magnetism, quantum entanglement, and possibly future quantum technologies. In a Tesla-like vision, Quantum spin liquid is another reminder that the universe is not always rigid. Even at near absolute zero, where ordinary motion should nearly stop, hidden quantum motion can remain alive, still vibrating, still fluctuating, still refusing to become still. It is as if the deepest level of matter contains a restlessness that cannot be frozen. Tesla believed motion was fundamental. He saw vibration everywhere. Modern physics, in its own language, confirms that stillness is often an illusion. Inside matter, fields tremble, particles fluctuate, quantum states shift. The world beneath the world is never truly silent. Then there is quark-gluon plasma, one of the oldest and most extreme states of matter known to science. To find it, we must go back to the first moments after the Big Bang. In the first tiny fractions of a second, the universe was too hot for protons and neutrons to exist as stable particles. Instead, it was a dense, blazing mixture of quarks and gluons. Quarks are fundamental particles that later combine to form protons and neutrons. Gluons are the carriers of the strong force, the glue that binds quarks together. As the universe cooled, quarks and gluons became locked inside protons and neutrons, forming the building blocks of atoms, stars, planets, and bodies. But in powerful particle accelerators, scientists can briefly recreate conditions similar to those early moments by smashing particles together at extremely high energies. In these collisions, protons and atomic nuclei can melt into a tiny fireball of quark-gluon plasma. This state lasts only for an unimaginably short time. Yet in that instant, matter returns to something ancient, a primordial soup from before atoms, before chemistry, before stars, before worlds. One of the great surprises of quark-gluon plasma research is that it does not behave like a simple gas. It appears to flow more like an almost perfect liquid, with extremely strong interactions among its components. This is profound. At the hottest known conditions, matter does not become random emptiness. It becomes fluid. It flows. It reveals structure even in chaos. Tesla's imagination was drawn to cosmic energy, radiation, and the electrical nature of the universe. Quark-gluon plasma belongs to a later scientific age, but it expands the same theme. Reality is far stranger than the senses suggest. Matter is not final. Atoms are not final. Even protons and neutrons are not final. Beneath them lie deeper forces, deeper particles, deeper symmetries. The universe is layered like a sealed notebook. Each generation opens one page and finds another locked beneath it. In August 2019, researchers from institutions including New York University, the University at Buffalo, and Wayne State University reported evidence of a new state connected to topological superconductivity. This kind of research belongs to the cutting edge of modern physics and quantum computing. A topological superconductor is not merely a material with zero resistance. It may possess special quantum properties related to geometry and protected states. These properties are especially interesting because they may help store and process quantum information more reliably. At the heart of this mystery are particles called Majorana modes, named after Italian physicist Ettore Majorana, who proposed particles that could behave as their own antiparticles. For decades, such particles remained theoretical, but certain materials may host Majorana-like excitations that could be useful in building topological qubits, quantum bits more resistant to environmental noise. Why is this important? Because quantum computers are fragile. Ordinary qubits can lose information through interference from their surroundings. Topological systems may offer a way to protect quantum information by storing it in more stable forms. This is not everyday technology yet. It is frontier science. But the implications are enormous. Faster computation, more powerful simulations, new approaches to cryptography, materials science, chemistry, and perhaps even artificial intelligence. Tesla lived in an era of coils and sparks, yet he dreamed of machines that would transform civilization through invisible processes. Quantum computing belongs to another century, but it carries the same spirit, using hidden laws of nature to create technologies that seem impossible until they are real. In Tesla's world, electricity was the gateway. In ours, quantum information may become another, but the pattern is the same. First, the force is invisible, then it is measured, then it is controlled, then it becomes civilization, and finally, there is plasma, the state of matter that surrounds us in the universe, though we rarely notice it on Earth. Plasma is often called the fourth state of matter. It consists of free electrons and ions atoms, stripped of some of their electrons, creating a mixture of charged particles. It behaves like a gas, but unlike ordinary gas, it conducts electricity and responds strongly to magnetic fields. Plasma is everywhere in the cosmos. The sun is plasma. Stars are plasma. Nebulae are plasma. Solar wind is plasma. Lightning is plasma. The glowing gas inside neon signs is plasma. In fact, plasma is the most abundant visible state of matter in the universe. On Earth, we often think of matter as solid, liquid, or gas because that is what daily life presents to us. But from the viewpoint of the cosmos, plasma dominates. This would have fascinated Tesla deeply, because plasma is matter electrified. It is matter made responsive to fields. It is matter transformed into light, current, heat, and motion. A lightning bolt can reach temperatures hotter than the surface of the Sunday. In that instant, air becomes ionized, molecules tear apart, electrons break free, the sky becomes a conductor. For a fraction of a second, the atmosphere reveals its electrical soul. Tesla spent his life studying such revelations. He built machines that produced artificial lightning. He stood near violent electrical discharges. He believed the Earth and atmosphere could conduct, resonate, and perhaps transmit energy. Plasma reminds us that electricity is not merely something inside wires. It is woven into the behavior of stars. It arcs through storms. It dances in auroras. It shapes cosmic structures across unimaginable distances. The universe itself is not cold machinery. It is luminous, charged, unstable, and alive with force. So what are we really looking at when we look at Nikola Tesla? A man? A myth? A scientist? A failed businessman? A misunderstood prophet? A brilliant inventor surrounded by legends he did not create? The answer is all of these. Tesla's life stands at the intersection of documented achievement and unanswered mystery. He truly helped build the electrical age. He truly contributed to alternating current, motors, high-frequency electricity, wireless experiments, and renewable power. He truly dreamed of wireless energy, cosmic power, atmospheric systems, and machines beyond the imagination of his time. He also made claims that remain unproven. He rejected theories that modern science later accepted. He became increasingly isolated. His personality and habits fed the legend of the eccentric genius. But perhaps that is why he continues to fascinate us. Tesla was not a smooth story. He was a storm. He reminds us that science is not only a collection of facts, it is also a battle between vision and proof, imagination and evidence, possibility and delusion, genius and obsession. Every great leap begins as an invisible idea, but not every invisible idea becomes truth. Tesla lived inside that dangerous boundary. He saw farther than most men, but not always clearly. He asked questions that changed the world, and others that remain unanswered. He built machines that worked, and dreamed of machines that never came to life. He was praised in his own time, then partly forgotten, then resurrected by a culture hungry for lost genius and hidden knowledge. And now, more than 80 years after his death, his name has become a symbol of everything humanity both desires and fears: unlimited energy, wireless power, clean technology, contact with the cosmos, control of nature, machines too powerful for politics, knowledge too disruptive for profit, a future that may have been possible, but never arrived. The central mystery of Tesla is not simply whether his lost inventions were real, it is whether humanity is wise enough to handle the forces it uncovers. Electricity gave us light, industry, medicine, communication, computing, and modern life. But it also gave us weapons, surveillance, dependency, and systems so complex that most people no longer understand the world they live in. Tesla believed nature contained hidden laws waiting to be discovered. He believed energy, vibration, resonance, and frequency were keys to reality. He believed the planet itself could be understood as an electrical system. In some ways, modern science has moved beyond him. In other ways, it is still catching up to the scale of his questions. We now study quantum matter, superconductors, plasma, cosmic radiation, wireless power, renewable energy, particle physics, atmospheric systems, and the electrical behavior of living organisms. The world Tesla imagined has not fully arrived, but fragments of it are everywhere, in the current flowing through the wall, in the radio signal crossing the sky, in the wireless device glowing in your hand, in the hydroelectric turbines turning beneath falling water, in the superconducting magnet, in the quantum laboratory, in the search for signals from distant stars, in the dream of clean, limitless power. And perhaps this is why Tesla's story feels unfinished, because he did not simply invent machines. He opened questions, questions that still hum beneath civilization, like current beneath the floorboards. What is energy? Can it be transmitted without loss? Can the earth resonate? Can nature be a source of abundance rather than exhaustion? Are there signals in the cosmos we have not yet learned to read? How much of reality remains hidden because our instruments are too crude, our imaginations too small, or our economic systems too afraid of abundance? Tesla's life does not give us final answers. It gives us a voltage, a pressure in the mind, a sense that the world is deeper, stranger, and more electrically alive than we were taught. And so the question is not only what Nikola Tesla discovered, the question is what humanity forgot, what it dismissed, what it buried under patents, debt, ridicule, and unfinished towers. Somewhere between the documented inventions and the legends, between alternating current and cosmic rays, between Wardenclyffe and the pigeons of New York, there remains a signal, faint, unproven, persistent, like a pulse from a machine still running in the dark. And perhaps one day, when science is ready, when ambition is tempered by wisdom, when power is no longer worshipped only as profit, humanity may tune its instruments again and hear what Tesla was listening for all along.